onto the submenu. Last video I covered the basic questions and did the menu bar, which was the trivial case. Now the submenu at first glance might seem more of the same, but the amount of data it needs spirals quickly. What do I need? Well, I need a string to show. I need to perform some action upon selection. I need to know what key also triggers the item. So those are the basic system inputs. What do I need to make it work? In order to display all the strings, I need to know how wide the menu is. I don't want it to have odd rows, so I'll need to know the max width of the strings I need to draw. Where do I draw it? It should be under the menu. Would be nice if it was centered. So I need to know where the middle of each menu item is in the menu, that is, it is being shown from. I need to know the full dimensions of the menu so I can apply a window to draw it. Performing some action. How do I want to link or define the action? What are my options? RTS dispatch. When you do an RTS, what the CPU does is pulls an address off the stack, adds one to it, then sets the PC to it. We can abuse this to make the PC jump to anywhere we want. Note I said adds one. So you want to push the address you want to jump to -1. The push order is high, then low, then RTS. This performs a jump. If you want to make a JSR, you need to push the return address first. Alternatively, you can just have each function jump to the next address rather than RTS. For small numbers, this works out cheaper in bytes, and it is always faster in clocks. How you obtain the target address is up to you. You could just store the address in your data and push it, or you could store an index into a shared table and load from it. If you have multiple menu entries that perform the same function, or if you have hotkeys, the index of the table would be better. This method has the benefit of being ROM safe and sparing RAM. Self-mod JSR. This needs RAM, but is very tidy. You simply add a JSR to a dummy value in the assembler and then modify the address prior to it being called. None of that -1 business, and no need to fake a return address. Order of write doesn't matter, but it does need RAM. If you are ROM bound, you can use a 3-byte island to mod and jump to. So the RAM code jumps and then you JSR to it. Uses 3 bytes of RAM, so hardly a big problem, unless you're on a VCS. If you have a 65C02 or 65CE02 or 65816 or 45GS02, well then lucky you, because now you have JSR pre-index abs X. And problem solved. In this case, storing an index rather than a pointer is superior, as long as you want under 128. Well, you want the index to be 2 times, which you can either store it doubled or double it before you dispatch. For my case, I am going with storing the address and RTS dispatch for training purposes. In order to do my highlighting, I again need to know the offset. This is because I'm just putting all the strings into one long string and then I just print it. Normally I give the raw bytes and then later do the automation option. However, this time I'm just going to go straight to the automation step, as it will show all the maths and logic you would need to do manually anyway. So you can either do this in the assembler or do it on paper or some other custom tool. I make a list of each string, the function I want to call, and the letter it reacts to. I could make it extract the letter from the string, but law of diminishing returns. Now, I've made a function to process and spit out all the data I need, as I will need to do it multiple times. A few placeholders for intermediate data. I extract all the functions and subtract one from them for my RTS dispatch. Declare my all-in-one string. I need to get the length of each string. Print length is because my strings have control characters which don't print, so I need to filter them out. Now I need the max. To work out the draw position, menu draw start plus half menu width minus half submenu max width, and then one more for the vertical bar. I don't want to go off the left side, so if it's negative, I cap it to 0. For each item, I pad the string out to the max length. You could do this with slicing, but for loop does the job. Then add the bars and reverse controls to append the full string. And get the reverse offset. Index times max width plus 4. The 4 is to compensate for the 2 bars and the 2 reverses, and one more to skip the leading bar. Then we return the data we need. Remove 1 from the max length to make it inclusive. With this data, I now instance and convert as I need. Start is just the first thing returned. The end is start plus width. I place the final drawstring, and don't forget to add the null terminator. I place the offsets. I get the number of entries. I extract the keys and the functions which have been adjusted. There is a dual nature to this. Things that have .byte and .text actually place data in the output file, and things that are equals are labels or lists defined in the namespace for us to reference elsewhere. And repeat for the other 3 menus. We now have all the data for all the menus, but they are isolated and separate. We need to tie them all together and link them. A list of all the menu address spaces. Again, we are going for struct of arrays. I pull all start x's, all end x's, the number of entries. I need the pointers to the all strings. To compare and contrast, I'm making a pointer to the list of draw offsets we made earlier versus a single list with per menu offsets, which I will now do for the keys and function tables. For each menu, I record the current length, which is 0. Then I add the first set of keys, and then it puts the number of keys as the next menu, etc. This gives me all the keys in one array, and then a list of indexes into the array where each menu set starts. Since I already have this array and there is a 1-to-1 match of numbers of keys to functions, I can also use it to index into the function table, which I high-low split out all the functions. If you're having a hard time following, pause now and look at the listing. You can see the assembler building the letters and offsets lists. Then for the window sizes, I just add them in. Pulling out the start and end, they all start on row 1 and the length is max entry, aka number of lines. Since the window is inclusive, I don't need to add 1. To access it, I just add kwindoset.menu1 to the index. How do we use this data? There are a couple of snippets I wish to highlight. However, first, a small implementation detail. I have a current header, which is the menu number, and then a current sub-menu index, which is the item in the sub-menu, where 0 is none and is the header still. So 1 is the first item. Setting and removing the highlight in the sub-menu. In the data, I store a pointer to the offset array for that menu. Are we going to remove or set? First, I make sure the submenu index is not 0. Note I use Y so as not to trash the A I just set. And if it is 0, then I skip to the exit, as 0 means there is no submenu highlighted. I subtract 1 from the header. You could pre-calc this in the data stored, i.e. the pointer actually points to the one before, but that is risky and only something I would feel comfortable doing once the code was complete and I knew all the instances I would use this data. I read the pointer into a temp 0 page location, index into the Y to read the offset, which I then store into Y for writing. I then load the string pointer into the same 0 page location, pull the value I want to write off the stack, write the value, and exit. A case where you can slide the maths into the assembler versus CPU is in the function dispatch. Get the current menu number, look up the start of this menu set inside the global set. Add the current index, remember that 0 means none and 1 means the first. But rather than dex, I can move this -1 into the address I look up. Functions high minus 1 plus x equals functions high plus x minus 1. So look for ways to offset any CPU maths into the assembler. I also use this technique in the keyboard scanning routine. When you scan the keys, I want to loop through all the keys, but only for the current active submenu. So I need a start, end, and end. With this code, we are given the key that was pressed in A. I get the current menu, then I want to get the end position, which just so happens to be the start of the next menu. So I add 1 to menu offset address and index into it to get the next. I store this into Y. Don't forget that Y has abs X and X has abs Y. They are very handy. I then store the end in a temp variable, read the start, and then start to compare the key. If I find one, I exit out of the loop. If I don't find one, then I skip past the section. Let's assume I found one. Now the index I have is into the list of all keys. I want to convert this to the offset in the menu. To do this, we subtract the first. Since I'm guaranteed to be at or larger than the current value, the subtraction will leave C set, as it didn't need to borrow it. So I can just add 0, which adds the carry to offset it by 1, since the submenu index is 1 based. I save the value. If needed, I clear the old one, restore the value, and set the new one. That is it for this episode. Join me for the next time where I start to delve into the dialogue system. If I've gone too fast or glossed over anything, let me know in the comment below and I will try and address it in a future episode or perhaps make a 3.5 or something.